element in writing programs. So it is important that we do learn how to write a function. And this function that we're talking about, it is very much similar to the mathematical function that we know about. What happens in a mathematical function? In a mathematical function, for example, here we can see a function which is f of x and y is equal to x by y. So here, f is a function. What are the arguments of the function? So the arguments of the function is x and y. And what the function is doing some operation on this argument. So basically here we are just computing the ratios of x and y, and then the function will give the output of the function will be the result of the result of this operation. So basically we will get back the ratio of x and y. So in Python we do exactly the same thing. We do have certain syntax when we need to write a function in Python. So basically when we want to define a function, we use a keyword that is called def, D-E-F, def. So define, when we're defining a function, it is defined with this keyword there, and that would be followed by the name of the function. So it could be anything. Here we have just given it a random name. We are basically trying to write a Python function to compute the ratio of these two numbers. So what we're trying to do, this is so def means that we are now writing a function. This keyword says that we are now defining a function. Then what we are trying to do is, now we will write the function signature. So this is the Python language. So what is function signature? This is the name of the function. It could be anything, it could be arbitrary, but you have to make sure that this doesn't match with any built-in function in Python or any keyword in Python. Other than that, you are free to use any arbitrary name. But it is better if it makes sense. So here we are naming it as ratio because we are computing ratio. And then in the parentheses, we have to put a parenthesis to input the arguments. So here the arguments are x and y. So we put x, comma, y, and then that will be followed by a colon. So this is basically the first line when we are defining a function. In the second line, you can see that we have written a string. So the string is basically explaining what the function is doing. It might seem like this is a comment. So basically this is a comment. In many Python scripts, you will write comments, and comments are helpful because they will tell you what you're doing. It's kind of helpful to understand the code. But when we are writing this line, this string here under this diff ratio or diff function, definition of the function, this is more than a string, more than a comment. So this is called a doc string. And what the doc string does, so whenever you have written a function and then any other user wants to use that function, and then if he basically writes help, so you have written this function ratio, and now you write help ratio, and maybe you can run it and see what happens. So first we have to connect this. We will connect our notebook, we run this definition, and now we will see what will happen if we write help and the name of the function. You will see that basically this returns this documentation string or doc string. So basically it is the documentation of the function. So that this is very helpful. You are writing a function and you want this function to be useful to other users, also to you. It should be useful for you. You don't want to every time go back to the function and see what it does. So you can just write the name, the help and the name of the function, and that will give you back that what this function meant to do. So this is kind of important that you do write a short explanation of what the function is doing. And we are using double quotation here. We could have used single or double quotation as well. But do you remember what would have been the problem of if we use single or double quotation in place of triple quotation? Do you remember from our last lecture there is a slight difference between triple quotation and this single or double quotation. So what would happen if we have multiple lines of this documentation and we use a single quotation? So basically, if you do want to write multi-line quotation or multi-line strings, you have to use triple quotation. That's why in many cases it's a simple function, but if it's a complicated function, there will be multiple lines where you will explain what the variables are, what would be the output, so you will have multiple lines, and you do want to use triple quotation so that it doesn't generate an error. And then the last line is return x divided by y. And one key thing is important to see that everything under this definition we have an indentation. So this indentation means that whatever lines include the indentation, this is within this function. And then whenever we are not including an indentation, then we are going out of the function. So this is also important. So now we have defined a function. So for a function, first we have to define a function, and then we can call the function anytime we want. So we will see how we can call a function. So to call a function, we will basically use the function signature that we mentioned before. Function signature is the name of the function and the arguments. So we have ratio, and we put the values in the parentheses, maybe 5 and 4. Then it will output or return 5 by 4, the ratio. We can try that. So we're getting 1.25. With this we can get 2, and here some float number, and this is what it's supposed to do. So this is kind of the how we define function and how we call a function. Any question? And now function does not necessarily, it doesn't need to have arguments. So in the previous function we had 2 arguments, but it doesn't have to have arguments. For example, here we just defined a function with a very long name. It's like the answer to the ultimate question of life, like universe and everything. And then we have this document string, and then we are returning 42, whatever happens. So whenever someone calls this function, it will return value of 42. It doesn't have any argument. So it is possible to. You can have a function maybe just to print something. So basically you can have functions without any argument or without anything returning. So these are other possibilities that you can have. So basically we can run this, and then if we call this function, then we will get back. So the function will return the value 42. And in the same way, as we say, function does not need to return anything. So basically here, we are just printing something. We are defining a function, and we are printing a dialogue from Julius Caesar's, a dialogue from Caesar, which is like about Cassius. So basically, if we run this, it doesn't return something. Rather, when we call it, we will see that in the screen, we are printing that line. However, if you print what is the return value of this, what is the return value of the function, this is none. So none in Python is a keyword, that means nothing. So it is not returning anything because we are not returning anything. So this function does not return. Question? So now it's your turn. You will write a function definition first. The name would be sum all. That takes a sequence of numbers, so basically a list, and it will return all the numbers added together. So this is our class participation. We will do a few problems, very simple problems today, and that will be our class participation task. So method we will see nothing happens. So basically we will see none. It doesn't work on this value. But what is being changed, I will just take this out, and I will print my list. Can you guess what will happen if we print my list now?
It's going to print out 4957. It's your original list on top.
4957?
Yeah.
But we're getting 4579. So what the method is doing, it is operating on the variable in its place. So it's sorted or sort is slightly different. I mean, in many cases, method and function do the same thing, but there are certain cases, that's why we have to be careful when we're using function versus method. In some cases, you will see that the method works on the variable in its place. So basically, when you do this, while this sorted is, maybe I will just take this out. So the way to use method is using my list and then dot sort. And what it is doing is using this will change my list itself. It will sort my list itself. We are not defining another variable to make it happen. Rather, it is taking place in the variable that it is operating on. So my key takeaway message is, in most cases, method and function work in the same way. You will see that like mean, median, that we will cover in our next part in NumPy. You will see that they give the same output. However, there are some cases like sort and sorted. They meant to be. I mean, it seems like they're very similar, but they're not similar because they are working in a different way. Where when we are using function, this is not changing or sorting the original variable. On the other hand, when we are using the method, it is directly working on the variable that we are associating with it. So question? And there are many different methods, and again, method is associated with certain data types. So for example, there are methods particularly for list. There are methods particularly for NumPy object. So method is associated with the object, unlike function. So for example, for list, this is kind of non-exhaustive list of methods. If S is a list, then we can do like S.append. So append is a method that adds a new element at the end of that list. So in this case, whatever the X is, it will be appended to the end of the list. Count, which will return the number of the time that X appears in a list. Extend, which gives an iterable of X to S. So there are these, I mean, for reverse, that will reverse the order of items in S. Sort, that we already showed, which is sort the elements or entries in the list in place. In place means it will change the original list. So these are kind of a non-exhaustive list. And this is another example where we have just appended one number here. So we can see that this 5 has been appended to the list. So this is all about the functions and methods. And if do you have any question or not, maybe we can go to the next one. Okay, so okay, so this is kind of very important because in machine learning we will use invariably whenever you would write a code, you will import NumPy, you will import SciPy, and in most cases you will import pandas. These are very important whenever we are doing any machine learning tests. So now, yeah, okay. Maybe we will skip this part. It is very similar, but maybe so I think we don't have enough time, but what you did already, you computed the sum using a function. So basically you can do the same. So write a function to compute a mean of a list. But what we want to show that if we use NumPy, then it is much easier. So in NumPy we have many different mathematical operations that is very easy to use, and that is also very computationally effective. So this is kind of, I mean, if you are using something like mean, standard deviation, exponent, cosine, sine, these are very common. I mean, you would say, I mean, it feels like it is something many people have done already. So if you think that this is very common, then there is a 100% chance that a good programmer or a team of them already have implemented something, in most cases in form of a method that is very computationally efficient, and also it has been tested. So it is very, I mean, well tested so that there isn't any bug. So you will, I mean, it is recommended that you use those methods rather writing your own function. It is a good practice to know how to write a function, But whenever it is possible, we will use those built-in functions because those are fast, those are tested, and easy to use. So how to use these packages? So these are called packages. So packages are basically, these are a collection of modules and functions that we will use again and again. So when we want to use NumPy, we will use this keyword, import NumPy. So what can we do if we import NumPy? When we have imported it, now all the NumPy packages are available for us. And if we want to access any of the function, we would always use NumPy dot. So that's the syntax to access any of the function available by NumPy package. For example, here we have a list, my list, and we want to compute the mean using the NumPy function, numpy.mean. So we will call numpy.mean, and then we will use the variable, use the my list that we want to compute the mean in the parentheses, and that will give us the mean. So basically, this we can also use sum or median or standard deviation or these built-in functions to compute this rather than writing your own function. Another important thing is when you have imported NumPy as it is, every time you are calling something, you have to write NumPy dot, and it might seem tedious. Another way that it's very common to do is use the as keyword. So we import NumPy as NP. You can import NumPy as something else like py or whatever you want, but it is very common that people use NP, so it's readable. I mean, if you do like import NumPy as NP, it is more easy to understand because it is kind of a very common practice, so maybe we'll continue doing that. So if we do that, and we can compute np.mean my list, then we get the same result, and later we will show that this is much faster too. And now we will talk about NumPy arrays. So NumPy arrays are very important because in our first lecture we showed that we do a lot of matrix handling and calculation in machine learning. So all our data, these are kind of, it looks like a tabular matrix where we do have multiple features and we have observations. So our rows, multiple rows are these are associated with multiple observation, and the columns, those are multiple features. For example, there are multiple people that we have multiple columns for single column for name, a column for age, a column for gender, and so on, and we have the observations like different person in the row. So we do need to handle a lot of matrices or multi-dimensional arrays. And for this, NumPy arrays are very helpful. That's why we do want to learn more about NumPy arrays. So how we can create NumPy arrays? That's the first question. We can create NumPy array from something that we already have learned. For example, we have done list. So we can do a conversion or casting. So for example, this is a list, 1, 2, 3, 4, that's a list with a parenthesis, and we can write np.array, and that will do a type conversion. And now if you run it, you can see that now this is not a list, rather this is an array that is kind of explicitly denoted by this array symbol. This is an NP or NumPy array. And NumPy arrays do have a lot of different attributes. So attributes are basically what's the value, what's the shape. These are the attributes, and also lots of methods that is associated with it. So we can do certain operations on NumPy arrays. So among the attributes, for example, the data type. The data type is, or that's written with .dtype. So we can find what is the data type of the NumPy array that we just defined. So this is a 64-byte integer that we found. Okay, that's good. What is the shape of the array? We just saw that it's a one-dimensional array with 4 elements. So we have 4 and comma because it's only one-dimensional array. If it was 2-dimensional array, we would see maybe 4, 2, or 3. So whatever the other dimension is. We can do data type conversion as well on NumPy array. So this is an integer. We can convert this to float by using AS type. So by doing this, now our array is a float. It's not an integer anymore. And there are many methods that we say. So how we write method? What is the syntax to write a method? We put a dot and the name of the method, and followed by the object. So now our object is my underscore r. So that's our numpy array. And these are the methods. So max, mean, sum. So this is the minimum, this is the average, and the standard deviation. We can do this operation using this built-in methods. We can run this and see that what values this gives. And so these are methods, and we also talked about function. So we can also use functions to do the same thing. It's basically exactly the same. So we can use np.max. So this is the function of numpy package np means. It's the same thing, but we are doing it in a different way. Previously, we were doing it using a method that is attributed to the object, where the object is numpy array. And here we are using the function, numpy functions, that is not associated with numpy array. It can generally be used in any other case. So we will get the same results. And there are also many other ways to make numpy arrays. So previously we showed we can just do type conversion from list, but we can just do it from the scratch. So maybe we want to make a one-dimensional array only with zeros, where the length of the array is 10. So we can do this np.zeros, and a parenthesis n, and n is the number of elements. We can, in the same way, create a matrix or one-dimensional array with 1, with the our syntax would be np.ones. We can create an empty matrix as well, or empty array using .empty. In this case, whatever the values were in the certain memory where we are creating this, it will just override or get those values. So these are random values. And this is important. We can make an array of random numbers. Many times we would be interested to make random numbers. But this is pseudo-random because you can regenerate this. How you can regenerate this? You can specify a seed, and every time you specify that same seed, you will have the exact same random number. So basically, it's random versus pseudo regenerated. So here we have specified. So this is the syntax. So basically, if you're not using Python, it will take you some time to get hands in the syntax. This is not a big issue. Whenever you don't know how to do this, it is very common practice even for very seasoned programmers that you just Google it to find it in Stackflow. It's not a very big deal. It's important to understand what is happening, but remembering or memorizing the syntax, it will just come as you do the practice. It is not very critical. It's just, it will happen. It takes time, but you don't have to memorize. Maybe we'll see the same thing again and again as you're doing the examples, and that will happen naturally. So here we are defining np.random that defines what is the random. So now we are defining something, the C basically, so this is the syntax. And here with np.random, and then 24, that means now we are defining an array of random numbers with the length of 24. And let's see how the array looks like. So this is the array with a random number, like 24 random numbers. And now we might want to access certain element in this array. So that's the slicing the arrays that we previously talked about for list. So this is very similar to list as well. So for example, what will happen if we do this? So here we are doing rand array, and then colon, and then the stride is -1. So can you think what would be the, so this is our array, right? So what will happen if we do this? We are slicing it, we are trying to find, it will be printed in reverse order. It will be printed in the reverse order, exactly. And now it's your turn. So we are doing exactly the things we did for the list. So you will print the elements from starting from the 5th index. Every 5th element starting from index 3. So you will write one line of code. It should be very simple. So you will print the elements of this array that will start at index 3, and it will take every 5th element. So I think it should take you 1 or maximum 2 minutes. Entries, all the entries from 10th to 20th index. And remember that the way Python does it, it is inclusive of the first index and exclusive of the last index. So when we are talking about 10, it will include 10, but when we're talking about 20, you will have to think that in the number you're indicating should, I mean, that wouldn't be included, so you have to define it in that way. So the last number is excluded when we are doing the slicing. So are we all done? Okay. Very easy problem, and then let's move on to the next one. We can do also fancy indexing. So what is fancy indexing? So basically we can exactly tell that we want maybe the first, fifth, and ninth element of an array. So in that case we can specify that which index we want. So here the first, the 19th, and the 6th element will be printed. So this is just a fancy indexing. And okay, and another very nice feature is sometimes you do want to check some conditions on an array. So that is, you can do Boolean indexing. So basically, you might want to check whether the elements of an array is greater than 0.7. So for which cases or which indexes this is true. So if we write this, rand array is greater than 0.7, you will find that at the indices where the element is greater than 0.7, that it will be printed true. In other cases, it will be false. And then you might just not want to see where this is true or false. Rather, you do want to print those elements which satisfies this condition. So using this, so rand array and then the bracket, and we write rand array greater than 0.7. So you can print that exactly which elements have a value greater than 0.7. I know if, as I'm going through this and I'm not, or you're not writing, it might not be very helpful. It looks like it's just going in front of your eyes. So I would kind of encourage, we will have a small example, but it is helpful if you kind of think about that this is the condition that I want to see and you just write it yourself. That would be very much more efficient to kind of translate this skill rather than just going through the course. And so basically, and then again, another helpful feature is end-to-where. So using this function, we can exactly see at which indexes this condition has been satisfied. So we are writing end-to-where rand array is greater than 0.7. So we create the zeroth element, the first element, second element, sixth element. So these are the elements, or the indices of the elements where it satisfies this condition. I will not go through each of this, but I would recommend you read through in your free time. So NumPy arrays are mutable. What does that mean? We can change the values that we talked about. So list is mutable. Tuple was unmutable, and again NumPy array is mutable. So maybe you just can go through the examples. And also slices of NumPy arrays are views, not copies. This is important because when we're taking a slice, so basically you are taking some elements and then you change those values. that will change the original NumPy array, because these are not the copy, rather these are the views. So that is something that you have to be mindful, whether you are just taking some elements and you're changing the value, that changes the original value. In some case, in tuples it will not happen, but because this is mutable, it will change. So basically you have to be kind of mindful when you change not only the NumPy array values, rather if you just slice it and change, slice it means you take another variable and save some of the numbers there. So you're slicing it and then change it. That will also change the original NumPy array. And there are many things that you can do with NumPy arrays. Again, I will just very shallow, I'll not go very deeper. You can go through, there are some nice examples. So you can just do regular arithmetic operation, like you can divide with so one NumPy array with another NumPy array. You can multiply with a scalar number. You can raise to the power, any power. And then now we will briefly talk about 2D. We talked about 1D NumPy array. What will happen if we have a 2D NumPy array? One way to create 2D NumPy arrays, for example, we have this random array which was 1D or one-dimensional. We can reshape that. So now we are reshaping that so that we have 6 rows and 4 columns. And if we try to see this, so basically now as you can see that we have 6 rows and 4 columns. So basically this is one way to create a 2D NumPy array from a 1D array. And how we can access this? So basically you can access this by using 2 indices. So first one is the row index, second one is the column index. Can you tell me what would be the output of this one? So we are trying to find what is rand array 2D. The 0, the row index is 0, the column index is 1. What would be the output for this? Without pressing the play. So 0th row, so 0th row basically is the first row, right? So, this row and then the first, so this is the first column. So we have 0.80, so this one, right? Sorry, we're talking about this one. So we have this element. And we can also access a particular row. For example, here we are accessing all the column elements for row 2. So this is row 2, index 2. So we have 556 this row. How we can print for a certain column? So you want to print everything. So basically, maybe you want to print this column.
A blank space and then comma, whatever column you want.
So you will have nothing on the first one and then
blank,
comma,
and then number.
Yeah. So column, comma, and then the index of the column. And we can also use Boolean instructions as before. For example, if we do this, we want to find which elements of this matrix is greater than 0.7. You would imagine that it will give you a 1D array because you are just finding it. Whenever you are indexing with one element, not 2 elements, so you will get a one-dimensional array because it will treat it as a one-dimensional array. So as you can see, we will find a one-dimensional array, and then using np.where, we can find exactly where the elements have a value of greater than 0.7. So this is what we're getting. So this says that which array, so like 0, the row with index 0 and the column with index 0. The row with index 0 and the column with index 1. The row with index 0 and column with index 2. So you can match with your original matrix that whether that's the case. So basically the first one says which row, second index says which column. So you can find exactly where those elements are situated. And this is giving you the index, not the values. How you can get the values? You can simply copy this. This is the position of the elements. So you can copy this. You can write np array, and this you just cannot write array. You write np array and copy this position, and then take a bracket or parenthesis, And then that would be your indexes of those elements. So basically you write grand array 2D and these are the indexes, and that will give you the value of those elements basically. So this is kind of, I think it will need some practice. I will let you do the practice as the last thing. Maybe you can go through this like mathematical function like np.exponential, so that will let you do the exponent on np arrays. You can do cosine, you can do square root, and this np dot that allows you to do the matrix multiplication, and np pi is just np pi. So maybe basically the last thing we would do is this exercise. So you will create a 1D random array of size 25, so length 25 more precisely. Your seed will be 100, so that everyone has the same matrix, sorry, same array. You will display that. So in the black line, you will write that code, and then you will display this. Then you will reshape it to a 2D matrix of size 5 by 5. You will display that. So basically, you should name the variable as this rather than so that we will have kind of similar result for all of you. And then you will compute the squared matrix. You will find the indices of the elements with value less than 1 e to the power minus 3, and then you will find the element with value. So basically, not the index, rather the element. So you will do this as the last thing. And what I will do in the meantime is, so you will have this assignment. So you will download these two, like you did one function for the first segment, and you did this one for the second segment. So you will download the IPYNB file for both of the cases, and you will upload this on campus. So we'll have the class participation task for this one. The due time is 3:35.